Welcome back. We're going to continue our look at exponential decay here, but actually in these exercises we're asked to identify the initial value in each formula, that means the starting amount, state whether the formula models exponential growth or exponential decay, and justify our responses. So looking at our problems here, A, B, C, and D, okay, we can use these, our exponential growth and decay formulas to kind of help guide our thinking. So remember, for exponential growth, okay, our formula was A final amount equals P starting amount times 1 plus R to the T, right? For exponential decay, our formulas were A equals P times 1 minus R to the T. Okay, so in other words here, 1 plus R means we have growth if this is bigger than 1. We have decay if this is less than 1. Okay, our starting amount is located right there in front of the parentheses, right, the P value. Okay, so let's take a look here, right? For letter A, right, what's our starting amount? What's the P value? Well, that's going to be 2. Okay, and then our growth or decay right here is determined by that 2/5. Now 2/5 is smaller than 1, right? Which means when we take 2 and repeatedly multiply by a number that's smaller than 1, what's going to happen to the overall value of this? If you multiply by something that's smaller than 1, or between 0 and 1, like 1/2 or 1/4 or 2/5 in this case, the overall value is going to get smaller. So this is exponential decay. Because 2/5 is less than 1. Okay? How about letter B? Well, again, starting amount is right there, it's the 2. Okay? And then what about the 5/3? Well, that is larger than 1, so that will be exponential growth. Because 5/3 is bigger than 1. Okay, go ahead, try and C, D, and E, see if you can figure those out. Pause the video and identify them as exponential growth and decay, and also identify whether they are, sorry, what the starting values are. Okay, so for C, that's our starting amount. For D, 2/3 is our starting amount. And for E, 3/2 is the starting amount. Okay, for letter C, okay, since we're multiplying repeatedly by 3, that's going to be an exponential growth. Okay, 3 is greater than 1. This will be decay, because 1/3 is less than 1, and this will also be decay because 2/3 is less than 1. All right? So that's how you can identify that stuff. Number 2, here we have an actual word problem. If a person takes a dosage D of a particular medication, then the formula F of T equals D times 0.8 to the T represents the concentration of the medication in the bloodstream T hours later, which is, not a inaccurate idea. When you take some medicine, right, it goes into your bloodstream, but your body eventually cleans it out, right? And so, you're going to lose the amount of medicine in your blood, which is why you have to take the medicine every so often if you, need to keep it up or whatever. If Charlotte takes 200 milligrams of the medication at 6 a.m., how much remains in her bloodstream at 10 a.m.? Okay, so let's answer that question. So dosage D. Now it doesn't say what the units for that dosage are, but I'm going to guess just 200 milligrams is what we're going to use here. So F of T equals, the dosage in this case was 200 times 0.8 to the T. Now our T, though, what is time here? If she took it at 6 a.m., how much is in her blood at 10 a.m.? What would T be? Remember, T is in hours. How many hours away is 10 from 6? That's 4, right? So we'll just do to the 4th. So we type that into our calculator here. 200 times 0.8 to the 4 Whoops. 81.92, and that would be in milligrams, right? Okay, so that answers the first question. How long does it take for the concentration to drop below 1 milligram? Okay, so that means how long, that means we're solved for t here. Okay, so we'll have to do a separate equation down here for this one. We want 1 milligram. We want it to be less than 1 milligram, right? So we want something like that, okay? And then, we start with, again, we'll say 200 milligrams to the same situation, times 0.8, and then to the t, right? We don't know the time yet. So we'll divide both sides by 200. So we get 1/200th is greater than 0.8 to the t, and now we'll use a logarithm. We'll just do log of both sides, which says log of 1/200 equals t times the log of 0.8. Divide both sides by the log of 0.8. Those cancel, and we'll have t is exactly the log of 1/200 divided by the log of 0.8. But of course, we want some actual meaning behind that, so we'll type that into our calculators, and here I'm just going to do it in my calculator right now. Divided by log of 0.8. Again, when you're typing this in your calculator, make sure you close that parenthesis in the numerator there. And I get about 23.74 hours. So almost 1 day later. Okay, almost 1 day later, it's almost completely gone from our blood. All right. In the next video, we'll take a look at the next questions here.